of you. Today's gate question is, in the circuit shown below, P and Q are the inputs. The logic function realized by the circuit shown below is, okay, so this is the circuit given. It is 2:1 mux. First of all, I'll see what is mux. What is the full form? It is multiplexer. Multiplexer. And digital logic design, mux or data selector. Mux or data selector is a logic circuit that connects one of n input lines to a single output line. Whatever be the logic present at that input, it's simply transferred to the output. Okay. I'll explain by a diagram. Suppose if it is your mux, let it be mux, let it be n:1 mux. So you're going to have many inputs like this. Yes, D0, D1, D2, D3, etc. Dn. And you're going to have only one output. So these are all inputs and this is output. Now there exists a data selector switch here. A data selector switch. Okay. And the data selector switch which, yes, here is a data selector switch which selects the input data. Based on, there exists another input here that is called select line or select input. So based on the select input, which selects one of the n inputs and sends it to the output. Okay, suppose if you have n input lines, how many select lines we need? If you have n input lines, the select lines are represented by m. The relation between n and m is n is equal to 2 power m. Means, if the mux is 2:1, what is m? 1. Because here n is 2. Suppose if it is 4:1 mux, you can take either small n or capital N. Yeah, you can take capital N also if you want. So here 4:1 means n is 4 implies as n is 2 power m, m becomes 2. Okay, you can represent the mux either n:1 or n by 1. So now what is the problem? Here the problem is for 2:1 mux. Okay, actually the internal logic circuit for this 2:1 mux is, see here, two AND gates, and the first input is D0 and for this the input is D1, and there exists select input that is directly given to the second AND gate, but it is given to the first AND gate after NOT gate, after giving it to NOT gate. So if it is select input, if the select input is represented by S, then for AND gate 2, the inputs are D1 and S, and for AND gate 1, the inputs are D0 and S bar. S bar. So now yes, these two are given to OR gate. What is the output? Output is Y is equal to yes OR D naught into S bar plus D1 into S. So what is the output expression? Output expression is Y is equal to D naught S bar plus D1 S. So now whenever the input select line S is equal to 0. So at 0 what will happen if S is 0? If S is 0 AND gate 2 output is 0 but AND gate 1 is output, because if S is 0 is AND gate S is 0, so this is disabled, and if S is 0 S bar is 1, so it gets enabled. So gate 1 output is D naught into 1, which is D naught, and that is given to this OR gate. So output is D naught when S is equal to 0. Suppose if S is 1, if S is 1 and gate 2 is enabled, if S is 1, so now S bar becomes 0. So the output here is 0, but here the AND gate 2 output is D1 into 1. So that is given to this. So the output is, so here the output is Y is equal to D1. So if S is equal to 0, what is output? D naught. If S is equal to 1, what is output? D1. So the functional table is S0 output is D naught, S1 output is D1. Okay. So now for our problem, what is Y? Here it is 2:1 marks. So Y is, now use the general expression of 2:1 marks for the given problem. So here the select input is Q. Okay. So you have to write, and in the place of D naught and D1 you have I naught and I1. So the output expression is I naught into Q bar plus I1 into Q. Okay. If you see I naught is 0 to Q bar plus, what is I1? I1 is P. So P into Q. So the answer is PQ. So Y is equal to PQ is the answer.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.